All right, hello everybody. I got two cameras going. One that's going is head on, and the other one that's kind of side panning, which is the one that uh, our one participant today, Kevin, is seeing me through. So last time I had two participants last month, um, and I nobody could see me on camera on the Zoom call. So now that I have two cameras, my face can be seen on Zoom and not on Zoom. But anyway, let's get to what this is all about. So I'm imagining most people, and I record these sessions, by the way. I'm imagining most people already seen the first two recordings. I did record the very first session, but I didn't, because I thought the recording wasn't clean, I didn't put it up, and I figured that the second session, even though nobody joined, I think there was a very nice elaboration about what these sessions are all about. I'm going to give a quick synopsis of all that, but for those of you who want to see the previous two recordings that are already up, I made a whole playlist on Neurodivergent Learning Series, and I will provide a link in the description to the YouTube video, which I'll be uploading momentarily after this recording. So for those of you who are watching this for the first time, I don't know how many will be. So let's go into what is neurodivergent learning all about. So I've made emphasis that some people, like myself, that struggle with neurodivergence, they have a hard time engaging with information in a very standardized manner as presented in public and higher education curriculum environments. So for me, I really struggled. I almost said struggled. I really struggled. No, I really struggled in that kind of structure where I was fed information. I was expected to take tests, and in a very rigid manner, I was supposed to follow the presentation of the information that was presented to me. And that was very frustrating, and I had a very hard time dealing with personal insecurities of how I was engaging with the world around me, most especially trying to understand knowledge presented to me, let alone people. I also struggle with engaging with people, but what these sessions are all about is to provide outreach to people who, like myself, have struggled throughout their life engaging with information in public and higher education environment, or even in environments such as online learning structures, whether it's like a boot camp ecosystem or brilliant.org. I think Brilliant presents information in a pretty interesting, visually oriented way. I don't use their subscription, but it's a bit hefty. You're paying $20 a month, and you're not learning everything you want to know if you want to deep dive into a subject. So problems with Brilliant is it's really just like a surface view of the content that if you really want to get into that content, Brilliant only takes you so far, but it's a good start. But it's an expensive service for those of you who are interested and know about that. But so, as I mentioned, the whole point of these sessions is to provide an outlet for people who are really struggling to engage with information in a very rigid, standardized manner that is structured for public and higher education system environments and other environments that are a little different, that kind of branch off public and higher education into their own thing, where there's these learning structures that maybe for some reason doesn't click for you, like boot camps or online learning environments, especially with Zoom University, which a lot of public and higher education environments have incorporated since COVID. I'm not sure how prevalent Zoom University is now, but anyway, that's a brief synopsis for the whole point of these sessions is to provide that outreach and especially going over different ways to engage with information that could work better for people struggling with neurodivergence in a way where there's difficulty engaging with public and higher education system environments thereof. And especially the second recording, Neurodivergent Learning Session 2, I think I gave a pretty nice overview of the stereotyping of learning, that learning has everything to do with how we engage and adapt to the world around us. It's not just about being fed information and learning a job or learning a set of skills for being employed, so to speak, like this generalization of what does learning really mean. I think it's important to get around that and really have a more open, broad understanding or general understanding of what, rather than stereotyped understanding what learning means. But I think it's important to emphasize that learning has much to do with how we adapt and engage with the world around us, because we're constantly, we're these autonomous beings that are constantly being bombarded by stimuli and responding to stimuli, and we generalize that stimuli to be information that may or may not have some relevance to how we adapt and survive and engage with others. Okay, now let's get into the content today. We're going to have a little bit of dialogue here. I have Kevin on the Zoom call. He is a fellow colleague of mine I've known for a number of years, so we'll be engaging in a dialogue shortly. I can let him give a brief summary of himself for the people watching the recording. But before we get into that, I wanted to kind of go over some content I wanted to get into. Last session, which was Neurodivergent Learning Session 3 in the series, I went over how can we go through loads of information, so much information, and it feels like so little time to get through that information. And I'm going to share my screen so Kevin can see what I'm sharing. I'm going to share my whole screen here. Okay, great. So I use Trello. Most people, I think, know that I use Trello to keep track of information. So in terms of dealing with so much information, last time we went over, okay, taking notes of like, all right, how can I organize the information? There's so many books and there's so many papers to read, right? Like, as I showed last time in the previous session. So I have all these books here. Oops, I just passed them. So right over here, I have a bunch of books here. I have over 60 books on my reading list. And if you're thinking I'm a madman for trying to read all these books sooner than later, you would probably be right. And I'm probably not going to read all these books sooner than later. But what I do is I try to find podcast interviews of the authors of these books as one strategy. One strategy I do to shorten it, to trying to understand the content that I find, rather than going through all these books and all these papers. I would try to find podcast interviews or lectures on YouTube. So this is one strategy that I highly recommend, especially with YouTube. As I went over in the last session, there's this transcript option, right? So if I open a YouTube video, right, if I go to YouTube, I'm going to give an example here. But before I go to that, one thing I started doing, which I'll get into that shortly. Okay, so I have all these books, I have all these articles. Most of them are papers, some of them are articles. And the way I shorten that time to read these papers and these books is, so here's one book that's on my rating list called active inference. So recently there was a podcast feature on Machine Learning Street Talk of Thomas Parr talking about his book Active Inference. What a coincidence. I didn't watch it yet, but it's on my watch list. And for me, since I just have this I'm better at digesting information through seeing and hands-on, and especially kinesthetically, like playing with the information with my hands and whatnot. We're not going to go over kinesthetic learning this time around, but the visual and the audio aspect of these videos, especially these lecture series. So over here you'll notice. And it's nice to use these, whether or not you use Trello or Obsidian or EndNote or OneNote or Dropbox. There's all these different technologies you can use to keep track of information. So I have all these lecture series on, different professors or people that write books. And I'll still make an effort to slowly work through the books at my own pace. But my main strategy generally is going through like video lectures and podcast lectures, and it gives me just it really cuts down how much content that I get out of what would be in a book in a shorter amount of time, because the way I'm able to digest the content quicker. And I did show last time. I'm not going to go through a YouTube video and show how to do the transcript, but basically what you can do is when you click on a YouTube video, you go to description, and then you scroll down description, and then there will be an option that says show transcript, and you click show transcript, and I think most browsers, unless you're on your phone, once you click show transcript, it shows up to the right on the browser page. So you're on like Google Chrome or Mozilla Firefox or whatever browser you're using, transcript usually shows up on your right, and you can do like so for instance I could do Control F, right? And I could search a keyword, right? And that's really helpful when I'm going through the transcript of the video. There's a certain term that I'm looking for that I can find in the transcript of the video, as opposed to, going through the timestamps, which is also strategic, right? A lot of these YouTube videos, they have timestamps, right? So you can go through the timestamp, you get to the timestamp, makes it easier to go through the transcript and do a word find, right? And that's like generally like Control F on your computer, right? That'll help you a lot. But more importantly than going through YouTube and video transcripts and what have you is using some kind of platform, because keeping track of information is one thing, but having a way to organize it is a whole nother thing. And so you see how I use Trello here, and Trello is pretty easy to use. You have these boards to your left here, and then you can make these lists, and then you make cards in the lists, and then you can put in. And basically, what's really cool about these lists and these cards, if I go through a card, I can link a card into another card. So, for instance, like you see over here, I have a couple cards over here, and I can click the card and it will take me to where the card is, and the card might be in a different board rather than the current board, which is watching, reading, priority list. This board is where I have all my to read and to watch stuff. Now, even more interesting, recently I had so many tabs open on my phone browser, and I was thinking to myself, what am I going to do with all these Stack Exchange posts that I don't need to read immediately? So I thought to myself, what if I made another list? Since I use Trello, for instance, and I don't have to use Trello, but I strategically made another list in Trello last night, actually, about, math sources posts to look into. So And since I go through math texts because it helps with my thought process, I made categories of cards of different concepts for different posts that I found that I had I had over 100 tabs open in my phone browser. So last night I spent about an hour, maybe a little longer than an hour, organizing all those posts in my phone browser. And I basically made these categories over here, and I sorted all those posts in these categories because I figured, I could probably move along quicker if I just sorted out all this information, this is going to get me into what I wanted to cover today, which is active learning versus consumption learning, right? So consumption learning is a very silly example is maybe I have some obsession in mind to build a sailboat, right? It's just to learn how to build a sailboat, but I spend who knows how many hours learning about like how to build the sailboat, like all the different mechanisms involved in building the sailboat and all the different parts and all that stuff, right? But I never actually build the sailboat, right? I just had this obsession of building the sailboat, but I never actually build the sailboat. So that's sort of a silly twist on like what does it mean for like like I'm learning how to build a sailboat, but I'm not actually doing the building of the sailboat, right? And there's no constructive goal aligned with that. As opposed to active learning, like there's a goal in mind and there's goalposts involved, right? And that's associated with my productivity, the tasks that I hold myself accountable for. So like with going through mathematics posts, like here, like I decided, okay, well, I didn't want to spend too much time going through certain concepts that I didn't need to go through immediately, but that could be helpful later. So I strategized on making these different categories of cards in this list. And this list that's math sources posts to look into. So with active learning, there's this constructive approach of engaging with material, and whether you're building something, or for me, I work on research publications in the cognitive sciences. So in terms of the content that I try to focus on is like building models that involves mathematical, taking mathematics and making structures and building models with those structures, and also looking at data, right? So I look at data and I use mathematics to make sense of the data, and probability and measure theory. Those are pretty important areas for me because using methods that involve active inference, variational inference, and Bayesian inference theory. So that's a lot of probability. And so I figured I instead of just jumping into a lot of different higher level probability theory books that are active inference and Bayesian inference and what have you, I figured I'd go through that material, but I also build from the bottom up. And as I'm going through that material, I would utilize these video lectures too to digest that material and build on that material as I'm building my models. And you guys probably saw over here I have outline for key models, right? So over here I put outlines for how I'm building my models, and I have cards linked together in here that basically kind of help me outline the models that I'm building. And I could go through, scroll a little bit through this. So I make all these notes and over here I outline how I'm going to build my models, and then at some point I throw those models together and publish a paper. So as I'm doing this process, as I'm constructing these models, right, I have a data modeling workflow over here too. This was something I threw together a while ago. But as I'm doing this, like the active learning aspect of doing that is like I'm actively being engaged in the process. Okay, like I'm doing something, I'm building these models, I'm publishing a paper. Uh, and like as I'm, I have this procedure of going through different textbooks and going, not just working through textbooks, but also finding notes online that can be helpful and intuitive for me to better work through the textbook information, right? Like as I'm struggling with concepts, what are easier ways I can learn concepts? Maybe I can find posts on the internet on reputable sources like Stack Exchange that, where people share insights on information. So, and like I mentioned earlier, I had like well over 100 tabs open on my phone, and I figured, well, there's a lot of interesting stuff I found on Stack Exchange and other sources, and I organized all that information based on its relevance. And so I made all these categories. So as I'm going through that information, like whether or not I need to go through it immediately, I have all these different categories over here. And then over here on the left, key general texts, right? So if I find myself like in a fork in the road, or I get tripped up over putting my models together, I have all these different additional sources to leverage for insights, that stuff not to go through super immediately as I'm building my models and doing the work I'm doing. This stuff I have on the side here, it just kind of helps me progress in a constructive way with the work I'm doing. So that's my whole bit on active learning as opposed to consumption learning. And okay, I have so much information, how do I deal with all that information? And I think the best general ways to deal with how do you work with a lot of information. You're not going to go through 100 books or 100 papers, immediately. You might go through some of those books or some of those papers, or you'll prioritize going through those books and papers in a certain way that works best for you. And the best way to strategize that is having a technology, some kind of platform to take notes and strategize that note taking. I think that's the most important, right? And you don't want to use post-it notes and write things down. You probably drive yourself crazy this day and age, right? Keeping track of stuff. So in terms of leveraging all that information, and especially using YouTube transcripts, and I think a lot of that was like an overview, but the new content I covered today was really in terms of leveraging active versus consumption learning, because I think what's important to note here is like this learning paradox, so to speak, right? A lot of people can find themselves obsessed with a subject, but not really progress anywhere with the understanding of that subject, like building the sailboat. As opposed to like if you actually have to prioritize your time to do things or work on tasks where you have a job, right? You can utilize information and resources to constructively leverage that task assessment and doing the job you're trying to do. That's really the big difference of active versus consumption learning, because it's so easy for us to waste time, whether or not it's dabbling in some obsession that doesn't really mean much. And I mean that can be just as bad as like spending hours as scrolling through social media, or whether or not you're a gamer, right? I used to be a gamer. I don't play video games anymore, but I could spend hours doing that, right? Like just obsessively playing the game or going through my social media feed, right? So like, okay, do I want to consume or do I want to actively be involved in doing something with my time? How do I prioritize that? How do I provide? And it's important to have a balance. And I do want to close on the points I'm making here on like having a balance in terms of like leveraging active learning as opposed to consumption learning. Not to just obsessively active learn, but like find moments where you can just take breaks and like reflect on like what you've accomplished throughout the day, and I mean that's really all basic needs, I suppose. Like that goes into the line of basic needs, but that's really the content I wanted to cover today. I didn't want to spend too much time since there's a moment for a dialogue, and even though it's just me and Kevin on the line today, and I don't think it's going to be too long. How long have we been recording? 25 minutes, just as long as last time. Okay. Yeah, let's kind of get on with the dialogue. I think I covered the content I wanted to cover. I didn't think it would be too much content, and I think I made the points that I think were relevant, and I think they were clear, and I guess Kevin will let me know if they weren't. But so Kevin, it's great to have you on, and welcome. I guess introduce yourself to the people who are going to be watching this later, and let's start from there.
Hello, I'm Kevin, and I am a computer programmer, but I do it in a unique way, and it's a little hard to describe, but basically one of the difficulties is the cloud is not really suited towards my way of thinking, and everything's cloud these days. Can't escape it. Traditional programming, maybe in the 90s, that the workflow, the way the thinking type and so on was more suited, I would say, although there's other issues. But the workflow today isn't, and I'm thinking of ways to address that. I could end up making some pretty interesting tools in the process.
Yeah, I wasn't sure if there was anything else you had to share, but like speaking of the cloud, Trello, of course, hosted on is by Atlassian. I don't know how familiar you are with Atlassian. I think I'm pronouncing them right, Atlassian. I believe Trello is a cloud service, especially since I'm using a service that's available through the browser or through their app. You know, like whether or not I access the service through the app, it's like the same content is stored and presented. I believe through a cloud environment, but I don't know how. I think I don't know if you use Trello or if you use other services that are kind of like Trello. I forgot, but I guess you can elaborate a bit on that and your experience with that.
So, as I was saying about the cloud, Trello, I don't know Trello in particular, if what problems it's designed to address. But let's talk about the problems I'm trying to address. So the cloud, if you're developing, it's called DevOps, I believe, in the cloud. Mm-hmm. It's really a different skill set, not just a different thing you're doing. I mean, we're talking fundamentally different skill set from programming before 2000, from like, let's say 1990 to 2000. When I was a kid, I was, or like I was born 1989, so I was a young kid in that era, and just, getting introduced to the concept of programming back then. But it's very different. So the way it is different is that in 1990, or let's say 1995 as a reference point, we had PCs, and you generally did your programming on the PC, develop an app on the PC, and then you release the app. There was web development, but wasn't as universal, and there's a lot more you were doing locally, and then you were releasing a fairly simple thing online. And it takes I would say a deep understanding, more like math, being a mathematician or being a physicist, a deep understanding of what was going on. And your tools were really well suited towards the problem at hand. I mean, the tools you were building were. I'll explain it. You understood how your tools behaved. You didn't have much in the way of black boxes, for the most part. Not to say that you knew every transistor of the computer, there's trade secrets and all that, but you knew that floating point arithmetic, if you multiply two numbers, it will approximately multiply numbers, and there's some rounding error and stuff like that. So even if you don't understand all the details, you understood it from a behavioral point of view, from at the level you needed to be able to work with those tools. And that was, I would say, the 90s in terms of being at the computer, developing an app locally, and so on. I'd say the peak was around that, somewhere around 95, very roughly. If you go back, we were talking about mainframes, and it was harder to, you'd have to go there, submit your program, and then they'd run the program. The program would be punch cards on paper, and then they'd have a guy go in and run the programs. No, actually, a woman. A lot of the computer stuff, both running programs, but also writing programs back then it was woman dominated, and so forth. And then nowadays everything's the cloud. So you're also doing less development on your computer because you're doing DevOps to get an instance in a cloud running. So there's kind of a sweet spot where you're doing more things locally. It's kind of easier from a logistical point of view, but then the challenge is understanding deep algorithms. Nowadays, the cloud is much more about logistics. Like, how am I going to keep track of all the secrets and passwords for the different instances? And how am I going to keep things up to date when I make a change? And how do I, transfer, what if I want to change the cloud from AWS to Azure or something like that? How would I go about this? A lot more logistical, and there's tons of black boxes everywhere. There are things that you don't really understand. Even open source can be black boxes because it can be so complex. There are things you don't understand. I liken this to biology. So you don't really understand how these things will behave. You have a general idea, or at least an idea of how they're supposed to behave. But in practice, there's all these configuration settings, all these things that can create unexpected behavior. So it's a very different skill. Much more about bolting together black boxes, much more about logistics, much more about that. And the way it's currently done, one would say the state of the art, is very heavy in manual labor, I would say. The level of automation was a sweet spot somewhere, around 2000 maybe, because there's a fair amount of manual labor in the days of punch cards, where bugs could be literal insects. At least that's what the legends, say. And there was a lot of, you had to manually fill in and, write the punch cards. It was just, you had to do a lot of work moving the stuff around, so on. And then in 2000 with PCs and so on, it was and developing offline apps, which were a big thing back then, even if nowadays feels like everything's an online app. Back then, offline games and hot seats and so on, they were significant. It was pretty well, there wasn't really much manual labor in that. But now with the cloud, there's a lot of manual labor. It's just disguised as automation, I should say. There's Terraform. That sounds like programming. It's not. I'm saying it right now, Terraform is not programming. Why is it not? Because it doesn't have Turing completeness, or if it does, it's really inconvenient to use. It's much more... It's declarative. You can't have a script that goes line by line. It doesn't have the core features that programming languages have. So then what people find is it becomes very tedious to do more complex things with Terraform. And if you just look at the cloud, even pretty experienced people are spending most of the time using a graphical user interface and doing things that aren't writing programs. So it's very manual. And there's a lot of manually copying files over to update things and so forth. It's just not the automation, the understanding of concepts, a more mathematical approach of programming took back in the day to a level that is in some sense a lost art, or a much less common art, at least today, because we're spending all this time trying to get black boxes in the cloud to do what we need them to do. So now that's in a sense, it's like a lost art. There was this sweet spot where programming was about deeply understanding topics, but now it's more just tedious work. And in the early days, it was a mixture of both. I would say you had to have deep understanding all the way back. But there was more tedium because you had mainframes, you had to do all this, mail your punch cards out and so on. But nowadays, I would say it's so that lost art, was thriving from 1940 to, or 1950 or so to 2010 maybe. But now it's like it's a lost art. It's like bolt together these things on the cloud. You're not designing algorithms. You're not using a deep understanding. You're just hacking it until it works. And that's not necessarily bad, but it's the loss of the ability to understand deeply. So how do I solve this problem? This is a big problem in my industry. There's a problem in my current job. It will be a problem with basically every job I seek. It's a big problem. I need to address it. I'm not going to solve it completely, but I need to get it down to a tolerable level so that I can enjoy my job, and so forth. And the answer, which I'm in a process of doing, is focus on organization and what I call process flow. For example, you're updating files on a cloud VM. That should be a script. So you don't have to manually update the files. And I'm in a process of doing that. I can get lazy and do things manually. It's okay to do a little bit, because part of the art of automation is knowing when not to do it. So you don't waste all your time automating things that are very small amounts of work. Small cognitive loads, you could say. But there's other issues, like there's services running on the cloud. If I update the service, I need to restart the service. So it's more complex than just syncing files. So it's not something I cannot just get a cloud file syncing tool. Mind you, these file syncing tools have side effects and bugs and other things, and they're very, very clumsy. That I can't just do that to fix my problems, because then I have to deal with Docker containers and updating this and that and so forth, and it just becomes it just is too painful. And this is one key thing, and maybe if a lot of people, even if they don't think differently or whatever you want to call it, could relate to.
I just wanted to say real quick. So I don't have Zoom Pro, but I did send you a link in case we get disconnected. You can click that link and we can keep continuing the conversation.
Okay.
I just figured.
Oh yeah, it has a limit.
Because the Zoom's gonna kick us out, but I made another Zoom and we could click into that shortly. But just figured I'd let you know.
Okay, so Zoom, I would say that what I'm trying to do is
Seamless. This is seamless, right? Starting. Great. Join speaker audio. Oh boy. Let's give it a moment for Kevin to get back on. Oh, here we are. Yeah, sorry about that, Kevin. That's what I get for not paying $20 a month for Zoom Pro. Yes, I guess you can continue regarding. You were saying about the cloud.
So as I was saying that the cloud is it lost the friendliness to my way of thinking, and other people with a similar way of thinking. It lost the idea of saying I'm going to understand something deeply. I'm going to dig in, get some insights, and I'm going to use those insights as these like flashes of brilliance, or whatever you want to call it. And I did well because I had that in my schooling. I did really well, got high GPA and so on. But the trouble is that that's not how the cloud is today, and I think that made it harder for me to get a job among other factors.
Dad would definitely be happy about.
And the cloud is really just, it's different than that. So then I think, okay, can I make this a process optimization problem instead of having more insights about how things work? Because either that's a huge amount of knowledge, which I just can't compete with the experts that way, and that's ever changing, or that's, I mean, maybe I can do it to an extent, but it won't be the main focus, or that's a huge, or it's just random. And I feel that way like with biologies. Are the people who have better experimental successes, are they really just luckier, or their lab is better at selling their results as a success, or seeing, I feel it's hard to say whether there is, the same skill. Like, can someone really understand it, or is it too complex? That's a mystery. But regardless, I don't have a natural cloud skill. I'm not naturally just really good at figuring out cloud configurations. So I have to focus on what I'm good on, and it's ironically getting stuck faster, you could say, and more reliably. So the workflow and the process and so on. For example, one thing I'm not doing is I'm not trying to rely on tools to do that for me that are these plug-and-play non-programming tools like a file sync. I have Dropbox for backups, but I could set up file syncing tools and so on. But that is not the right strategy. This is a big problem in the cloud, is they make a product for everything. AWS, I think, has 200 cloud products or something, and we don't need a product for everything. We need to allow people to use, do these things with our products, make our products more modular and flexible. But it's just not, they're not designed to do that. There's the paradigm is, oh, you need this slightly different thing done, make a whole new product. And you have to learn a product, you have to set it up, and it doesn't integrate well with programming workflows, so, writing scripts and so on. The cloud is not programmer friendly in a sense of, they're thinking first in terms of people working with IT and the tools. And they're thinking second in terms of people working with programming. They have features, but they're hard to use. And Terraform's a good example. They could have made a Python library, but they didn't, and they made this halfway programming language just because, they didn't want people actually program, and it's a mess and so on. But the engine behind is very powerful. So if I could somehow use the engine without having to use Terraform as a script, it would be good. So I would say that the programming is the programming feature, the programming language, the process control and so on. One thing I'm trying to do is basically have scripts for updating things properly. So I could have a script I could run, and it updates what, it could tell me what I could tell it what I want to update. It would automatically handle that. It would copy over files. It would, close and reopen things and so forth. That's one tool I'm working on. Another tool, which is going to be harder, is something that automates or that allows me to put breakpoints and debug the code in real time in some Docker container, and I'll have to figure out how to integrate this into HTTP protocols, because I'm communicating with HTTP to and from the Docker container and all this other stuff. And this is stuff that normally isn't done. And this is all programming heavy. I'm using libraries when I can, because I don't want to reinvent the wheel. But I'm doing a lot of reinventing of the wheel because the alternative is not a library. It's something that simply is hostile to being used by a programmer. It's like, here's a button. Okay, what command do I run? What Python library is this? What PyPy? No. Here's a tool. Here's a button. Okay, how can I what's the install script so I can automatically install this tool on my things and then have it and then call it from a command line. And maybe there's something there, but it's hard to find, and it's not built for programmers. It's not like, here's a command line, here's that. And I'm trying to gradually shift this and start with the fairly common tasks I have to do, like updating certain things, updating GitHub repositories, pulling from GitHub repositories, and just gradually organizing this through Python scripts and step-by-step English instructions when I can't automate things easily, or it's too much work, or I plan to automate it but not yet. So that's how I plan to fight back. Think of this as a process control. There are tasks I have to do to get a cloud thing working. And some require luck or knowledge that I don't have. Because, if a Docker container doesn't connect with the host, well, why is it not connecting? Oh, well, that turned out to be an IP being misconfigured, but I had no clue that was what was happening. There was no hint. There was the error message didn't tell me that. So for those cases, I'm stuck. I can't do anything. The best I can do is to make it faster to get to those cases, to give scripts to reproduce those cases so other people can reproduce those cases much more easily. And if I get stuck, to say, to my coworkers, I'm stuck here, here's a script. And that's useful. It may not sound useful. Like in academia, they value being able to finish. But in industry, they value being able to reduce the number of hours that the other people are working, basically. And in terms of, well, this is not a complete result, it has this flaw, it doesn't work. In academia, that's more of a problem. I wrote a paper and it's a flaw. But in industry, you can get help more easily in many cases. And I can say, look, I got stuck here. I have a flaw. And I got stuck here, I have a flaw. And it will be and that's useful because I got there faster. If I can get to the point where I'm stuck faster and make it easy for them to reproduce a problem, and then they can use their expertise or guessing or whatever it is, and maybe sometimes I can do that for their problems. They can use my scripts and so forth. that's very useful, because then their task, from their point of view, instead of having to build something, they had to fix a bug that I got stuck at, and I explained why I tried, and so on. And that's a big reduction in work. So that's useful if you can do that. As someone who's more of a programmer and doesn't like black boxes and so on, you can do that. Now, so that's, in short, that's how I'm leveraging my strengths in the cloud. How I'm leveraging my strengths to manage to acclimate myself to a different environment is in two ways. One is just finding something to do in an environment that is maybe different than what I am used to doing or was used to in undergrad when I was doing so well. And two is finding ways to make the environment more like, my home. And three is smaller and is finding ways to adapt just psychologically. But that's smaller contribution, because in programming you have a lot of control over the environment, and that's a key thing to realize, is that if something isn't suited to one's way of thinking in programming, there's ways to customize and other things, reminder notes, or there's all sorts of tools that's harder to do, not impossible, but harder to do for real life tasks.
I can.
I think you went mute, but I was gonna ask, given that you feel that you've had problems with, like container environments that basically try to modularize the space, like how the scripts kind of get together. So you're trying to like connect. You're trying to have apps that you take code that's like disjoint, but you have to try and find a way to tinker with the scripts in the way that you can have the scripts be accessible to the container environments you're trying to get the code to work in. I'm wondering if you had experience using WordPress environments in PHP, and like how do you feel that sort of environment working in PHP as opposed to being in JavaScript land? Or I know you had a lot of experience working with in a closure. I'm curious about that, because when I think of like when I'm working with a specific platform that is scaffolded for me to build a website on, and I have all these different components. Most people are familiar with WordPress, and WordPress is built on top of PHP. I might have
For those tools, there's a couple issues. First of all, there's so many tools, and it's very hard for me to search for tools that are suited to my way of thinking, because it's hard to put into words. It's hard to explain to other people. It's hard to Google. So I don't know. When someone says this tool and I haven't heard of it, or I've heard of it but I don't have experience using it, the first kind of thing is I don't know. It's difficult. They advertise specific features, such as being able to get a certain bandwidth, or being able to be resistant to certain kinds of DDoS attacks, or what encryption they use and stuff like that, or other features. They can do certain things with colors or whatnot. I'm not sure what kind of features. There was a time that 3D was a hot word in video game. Like, oh, this is 3D graphics is so cool. Now it's like, well, it's just trivial to have 3D graphics. But regardless, that's a tough problem, and curation is something that's part of my workflow design. Is just have a better way of searching and for these tools along those lines. The trouble is that with these tools, it's very much, with the cloud in general, it's very action at a distance, where you upload something and then you check a web page to see if it works. But whatever's actually going on is very far away from you. It's at some instance of something. I'm working on a tool, or this is a long-term project, it's not just one tool that's plug and play. That's a mistake people make when they're developing cloud tools. They try to make everything plug and play and it just doesn't work. But I'm working on a tool that, or a series of tools that, with some configuration and programming and so on, and maintenance, tools that require maintenance to keep working on the ever-changing situation, but hopefully a minimum amount of maintenance, will allow me to basically run code right and test code and debug and breakpoints right in front of me, no matter where the code is. And this is again one of the issues that comes up, is that I use an editor that has debug and breakpoints in it, but I can't easily figure out, this is VS Code, same problem with most editors, I cannot easily figure out how to utilize an editor. How do you use that as a library? Like, what if I said, okay, I want a function that I want to use the editor's library to write a function that, given the code, given a folder and a file and a text, will tell me the pop-up hints. That's one valuable feature in an editor, and it's kind of hard to write that manually. So I want to use the editor as a library that I call from Python or any major programming language. It's a Node.js, but when you're good at programming, which language is kind of a secondary concern. If it's a language you're not familiar with, you can pick up faster because you already picked up several languages and so on. But regardless, let's say Python, okay, I want that library function. Well, the trouble is these tools that are so built around non-programming use. Ironic that tool designed to write code is not built around programming use, but it's because it's designed to be used by a human typing and with boxes that they insert text into. It's not designed to be used headless or something. Maybe there is some sort of adaptation, but it just becomes hard for me to figure this out. Now, one could write programs they're not that way. They have a fairly thin GUI on top of rich libraries that you call, and I think that's a better paradigm because it better separates that. But I don't think VS Code is written that way, as far as I know. And if it is, I struggle to see where that separation is in the program itself. Instead it's written more like, it's not poorly written code, but it's written more like, I think it's more like modules and each module handles the visual and also handles the logic of how the components work. And that's a fine way of organizing if your goal's the same goal as the VS Code developers, right? So I'm not complaining about that. The trouble is if your goal is to use it as an engine and say, okay, I want to use that auto hint feature, I want to use that refactoring feature. And then I want to plug it into my own interface and maybe interface it with commands, so then I can start running it on server, on instances and using the debug feature and HTTPSing into the stuff and to keep the code in front of me. But it's just not built that way. So I really have to do a fair amount of work. It's going to be a long-term project to gradually make the cloud more and more friendly to me. I get overwhelmed if I try to do it all at once. But if I say, well, let's maybe take the easiest, annoying, tedious thing about my cloud stuff. And right now that's updating files. So I develop files locally and test them locally, and then I have to make sure it works in a version that's running remotely on an instance, AWS instance, another one that's running on a GCP, Google Cloud instance. So I just have to work on, so let me just make that easier. Let me just have scripts to automate I also have things that go to containers and go to machines and go to. Let me just automate that. It's not a big task to just do that, and it doesn't solve my problems, but it does at least make it one thing a little easier. So that's stuff I'm that's going to be like what I work on next. Like it's a long journey of 1,000 miles. Okay, what do I do for the next mile? Okay, I'm going to do that. That'll be my next medium-sized task. Task I could do in a day or two, kind of thing. Or even a couple hours if I'm quick.
Would you say that has to do with, like, do you think at some point there's some way of optimizing cloud, well, in terms of, like, the scripts you're writing, whether, like, there's different, like, there's scripts written in different languages because they have to be written in different languages, but there's there's like an intermediary script that you have where both languages are translated to, like, like you have like some embedded way of optimizing how the different how the pieces on the cloud is communicating to a process that's not running on the cloud, right? So I think this is sort of leans towards embedded systems. Like, I don't know if you play with languages like C or C++, and mind you, I'm not a programmer. I have a good understanding of how programming languages work and work together. For me, the problem is building things with code, because, as I mentioned to you a number of times, and we were on a call the other day with, I think it was Sunday. We were on a call with Ryan, who was new to our server, and I had this problem with being an engineer because I have trouble thinking in step by step, like following strict protocol, like strict step-by-step protocol. Like, I can think about methods and how a system comes together from a higher level and describing certain aspects of the system, but in terms of implementing the system, that's where that's kind of where things fall apart for me. But it seems for you that feels more natural. So, but I'm wondering, like, in terms of, like, struggling with implementing.
So I would say several things in terms of the engineer following protocols. The key, there's a big difference between understanding, being able to design protocols, and actually consistently following protocols. So in terms of consistently following protocols that are already there or that you have designed but are relatively easy to design, and most of the challenge is to be just very consistent, precise at each step. Biology in the in vitro world in particular, cells in a dish aspect, really requires that. You have to be very precise, and mistakes will produce all sorts of problems that are difficult to pin down. But in terms of understanding what protocol needs to be followed, coming up with protocols, designing protocols, saying, what's a protocol for simulating gravity between planets, Newtonian gravity? It's a differential equation, but okay, d, the acceleration is the sum of the forces. Okay, but what's the actual protocol there? Well, you have to, what do you need to keep track of? Okay, you need to keep track of their position, their velocity. Okay, so the force is going to change the velocity a little bit in each time step, but just knowing to do that, knowing to have time steps, knowing that. But you're not actually following it. Your computer's the one who's diligently following that protocol. Now, the cloud is kind of like biology in this way that because things are so easy to break, if you don't diligently follow these instructions, things will often break in ways that are difficult to assess. And that's really where you get punished for making a mistake, because you can't correct it very easily. If it was an obvious, and programming in 90s and or 2000s, especially with Python programming before the cloud really became huge, that was like a sweet spot, I could say. If you make a mistake, you can usually figure that out. and more so when software wasn't as complex back then. You could usually dig in and figure out where you made a mistake. So it actually was forgiving of errors in writing a protocol. It required that you understood how to write a protocol while being forgiving of making mistakes. And indeed, my undergrad was that way. It required to get a good score on tests, you had to understand the process. But if you made errors, like an error in a calculation, the way they graded it is they were generous with the partial credit, but the averages on the test were 60%. So if you think about it, an A was around 80, I think. You had to do well on the tests. You had to understand and set up, to get that A. You had to set up the steps and so forth. But if you made a mistake following those steps, I mean, you had to follow them, but if you made a mistake along that path, you got an you could get a solid A that way, even with getting all the answers wrong. And then on top of that, I came up with ways of checking whether the answers made sense, which you can't really do as easily in the cloud. So that's one key difference. Like, the cloud requires following protocols more carefully, otherwise you make a mistake that's hard to that generates a bug that's often hard to figure out what the heck's going on. Permission denied. It's like check engine light. You just don't know what the hell's happening. There's a chance.
We
With
have this like
algorithm design, it was more forgiving because if you did make a bug, it would have an obvious failure that you could track down fairly easily. But on the other hand, you had to have a good understanding of what you were doing and why you were what your protocol was and why you designed that protocol that way. Another thing is that when you say different programming languages, that's a secondary concern in the cloud. Getting programming languages to talk to each other is secondary. The main pain points of the cloud are, one, black boxes. Things can fail and it's unclear. I don't have a good solution to that at this point. There's so much proprietary, so many black boxes. I think in the long run, open source will win, and software will be more transparent, where you can dig into a software as it's running. Mm-hmm. Python is very transparent. C++ isn't so much, but there are going to be tools that can, like, there will be tools to analyze memory and so on. Also, C++ will be more and more for libraries, for functions that behave in very consistent ways, so they're not black box in their overall behavior, even if they're black box in their inner workings from the point of view of most developers. Like, a matrix multiplication does some subtle for loop tricks. It doesn't just do a simple for loop. It goes in blocks in certain ways because of cache locality. But from a point of view of what does it do? Oh, it does a matrix multiplication. And if you know linear algebra, you know what that is. Okay, what's a rounding error? Well, it's about what you'd expect. There's a little bit of cumulative error, but it's not that bad. So, okay, I have a sense of what it does. But with the cloud, it's black boxes in behavior as well as implementation. It's like, why did Docker, even us open source, I think, why did Docker do a certain thing a certain way and give me a cryptic error, and then I had to have someone else help me with that? Well, because just the cloud does that. So that one I don't have a good solution to.
So let me ask you this then.
I don't have a good way of solving that. If I did, that would be an automatic job if I was really good at that. Just I could just be a consultant and say, okay, I'll debug your cloud. But what are you saying?
Yeah, so I'm thinking, like, you're always thinking about, like, you have, like, this diagnostic mindset, I guess, like, going into following these strict protocols, kind of like a mechanic. Like, you're, like tweaking the problems and, like, tinkering at it. So, like, in terms of, like, this procedural, dynamical, diagnostic mindset, and I'm sure, like, how do you, like, take note and do, like, reporting of these things, right? Like, is there like a certain process that you feel like helps you keep track of, like, when you diagnose certain problems, or you have a hunch that something's going to go wrong a certain way, like is there a surefire approach of going about that, or is it just kind of like sort of like a strategic game of chess, like in a way, like trying to gouge, I guess, at that aspect of how you go about, especially with like considering like, okay, like I have to deal with the cloud, and the cloud is a little tricky because there's certain ways that there's a certain particular way that things are scripted, and you might have a way that you might want to write your script, but it has to follow certain protocols. It has to follow. You have to use certain. You have to use certain libraries and whatnot that are compatible to what's on the cloud, right? Especially like the version control, whatever libraries and exports and whatnot you're using, like in your code, like with your script, that like it has to be compatible with what's on the cloud. Like I'm interested in like, and we have a little less than 10 minutes, but I guess like you can go into that. I'm curious, especially like the diagnostic mindset and like reporting, like when you provide documentation.
Okay, so I don't have a good solution besides just keeping track of what my bugs were and how I solved them. But the trouble is the space is too big. There's so many products, there's so much that just won't really generalize. We're talking, you'd need like 1,000 times as much training data to really comprehensively squash the bugs or something like that. The other big problem with the cloud is version control, I'd say. Now, Git is like version control. Basically, making stuff up to date and so on. That can be addressed. I think that's the easiest part to address, because you just have to have a bunch of update scripts, and they don't even have to be fully automatic. You could just call them. I mean, it doesn't have to automatically detect when. To be useful, it doesn't have to automatically detect when an update is needed. You can just call them periodically, and if something breaks because it got updated and it shouldn't have, then you can go and start debugging and developing, because you shouldn't be forced to work with older versions. You should be able to update everything to the stable.
Especially if there can be like security problems.
The stable,
right?
I'm talking to the stable, not to the beta, unless you're testing the beta.
Right. Sure. Yeah.
But security, yeah, like. You should have these tests and so on. So that, I think, is actually the easiest problem, and that's why I'm tackling first. Let me just get that easy to do. The middle difficulty problem is, I would say, not having the code right in front of you. Meaning, like, if I'm writing something...
So it's almost like a black box, but not...
One common thing is, if I'm writing a function, I can forget what the inputs are. A strongly typed language can fix it somewhat, but it's got other challenges. There are downsides. So, like, in the net balance, I don't think it's a good idea, although there's use cases where it is. So that will be one issue. So that's the middle ground problem, because I'll have to set up communications between running processes and other things. That's considerably more work. But I still think it's tractable. Like, as long as I can... If I cannot set basic communication between things, then I won't be able to use it at all. So for things or surfaces that are working, I should be able to like sneak that in somehow. But the hardest problem, like I said, is fixing cloud bugs. Some network configuration doesn't work quite right. That's really hard, and I'm not addressing that problem directly. Instead, I'm trying to say, I want to be in a situation where if I encounter such a bug, I can make a script fairly easily that reproduces a bug, and I can give it to other people, and they can run the script and get the bug. And then they can maybe have some idea or guessing or whatever. And if I really get stuck, that's the best I can do. To do that, and that's good enough, I would say, in most cases. Like, if it's an easy problem and I really can't solve it, then from their point of view, okay, it wasn't too hard, and we helped him unstick, and he can continue, and he did the other 95% of the work, and that's good enough. useful. But if it's a hard bug, it's difficult to solve, then their point of view is like, well, this is difficult for all of us. So, like, they won't blame me as much for getting stuck, in some situation that I really feel stuck in. And okay, this is just a really hard thing, and we don't really know how to solve it. Maybe we can have a workaround, or not have to make use of it, or something. So it's just a useful thing to be able to give bug reproduction scripts to other people, because instead of saying I'm stuck here and forcing them to configure and set up and so on, you can say, run this script, and this is the bug it produces, and this is a bug it shouldn't produce. If that makes sense. And so it's less work on their part. So even without fixing that problem, I can make it so encountering that problem minimizes how much other people are inconvenienced. So even if I have to hand it off at that point, you're on a team as when you're working with coworkers. You're not each doing one thing alone. You're on a team, and you are expected to help each other if you can give that help reasonably. Yeah. So it's fine to do that. So that's my overall strategy. Like, one problem's easy, I can solve that in the short term. One problem's medium difficulty, I can mostly solve that in the long term. And one problem is hard. When I say easy, I mean medium, and medium's hard, and hard is super hard. So medium, hard, and super hard would be maybe better to describe. And one is super hard, and that's the one I won't really solve until I'm really way down the road in my career. But I don't have to solve it to be very useful. Solving it gives me an extra utility that I will, and that may just more be just pure expertise, or maybe hopeless, and it may just grow too much. AI is another black box I use to help me, as a reference guide and so on. So many black boxes.
Yeah.
But yeah, so that's my strategy. Solve one problem, in the near future. Solve one further down the road, and one may never be solved, but it's tolerable if I cannot solve it.
So there's a few minutes left on this call. I'm wondering, given do you feel that there's going to be a problem for people to transition with the demands of work now, with increasing capabilities of generative AI and programming, and the expectations that employers, businesses are going to expect from...
It's hard to predict the future, but I think it currently is a problem. I see quite a few people with deep understanding of core concepts, or who approach problems that way, but they don't have a large body of shallow knowledge, which is what you get if you have extensive cloud experience. That's why there's these experience requirements that can sometimes be ridiculous, as in older than the language itself. There's stories where someone said, well, this language didn't exist, and they ask for more years. I don't know how common that is, but companies it's currently a problem. But I don't actually see the problem as getting worse in the future. The reason is, I think there's going to be a renaissance of having to deeply understand algorithms that is going to be brought on by an AI winter that I predict is going to happen. So AI got a lot more powerful because of its training data being much more expansive, but that cannot scale very much more in the foreseeable future. So there's going to be an AI winter, I predict, when the algorithms can't do a lot. If the brain has quantum stuff, then the algorithms cannot do that because they're written on classic
We
computer.
have less
They were
than
on
a
class
minute,
computers.
and I think that the library's going to close soon. But I'm so happy you joined the call, and we didn't really get much participation. But thanks for everybody watching this, the recording after the
Okay.
fact. But I'm sorry to cut you off there, but the call's going to end. Well, the Zoom call's going to end soon, and the library's going to close soon. And I really appreciate you jumping on the call. Well, cut him off. Well, hey, thanks for sticking around. And for those of you who are into engineering, I think you might have gotten a lot on this call. And I appreciate you joining the library that I am hosting. The session is about to close soon, and I have some errands to do for the rest of the day. But thank you again, and I hope, as always, I appreciate feedback I get, and I think a lot of people are going to get more out of the upcoming recordings of the series. And until next time, thank you.